Hello. Today we are going to be working on a doorbell, old-fashioned doorbell. Not wireless, but an old-fashioned wired doorbell. And this house is 40 years old, and there's just nothing. You click on the thing and nothing happens. And so the first thing we're going to do is to look at the switch outside and see if we can get that to work. Maybe that's the problem. Then if that's a problem, then that's all. And we don't have any other issues. So let's do that. Okay. So we're going to pull it out of the wall. Has two little springy things here that holds it in this cavity. And here we have the two wires that's hooked up to this right here. And all I'm going to do is take my screwdriver and short out these two guys here. This is exactly what the switch does. The switch basically just connects 2 points. So this way, I'm just going to use my screwdriver and mimic what the switch would do. If I could make it hear the bell go off right now, then that means the switch is bad. Okay, the switch right here. But if since I don't hear anything yet, then we know it's not the switch, because I just shorted these two out and nothing happened. Okay, so get out the ladder here. This is the unit right here. This is the doorbell, old-fashioned doorbell. You can kind of tell by how brown it is. Probably used to be white at some point, just like this smoke detector. Anyway, we're just gonna pull this off the wall like that. Here's our unit right here. And really what we want to do, we want these plungers to do that. And they're not doing that. Okay, so what we're going to do is we're going to take this off the wall, and it's got two slotted screws that we know. Then we know that it's old because of the slotted screws. So I'm going to take this off right now. All right, I had to shut the power off so I can measure this, and so that's why I have my little lamp on so we can see what we're doing. And now we're going to just double check to make sure that the power is actually off, and we have 0 voltage right here. Line voltage now, it used to be 120, now it's 0, so we know it's off. Okay, so now we're going to take the meter and we're going to put it on resistance instead here. We're going to measure resistance. So right now it says OL. Okay, so that means that's an open connection, means it's open, not measuring anything. One thing I would always recommend when you use a meter is to make sure that these wires are actually working, because sometimes these break and then you'll measure nothing and you'll think there's something wrong and you'll troubleshoot for a day or 2 or 3 or 4 when it was just these wires that were bad. Okay, that happens. So what you do is that you take these two wires here and you touch them together. Okay, I'm just going to put this right here on this, touch them together, and you'll see it measures 2.3 ohm. Okay, that's not really that good actually. It means that we still, one of my wires is not that good. Really, we shouldn't be measuring 0.2 ohm. But for what we're doing today, it's okay. All right, we know it's measuring, so we know we have a connection here, right? So let's go and try to measure this instead here. So now we're going to take, in order to get an accurate measurement here, we'll take this wire off of this transformer. Here, just like that. Again, it's flathead screws, which I hate. Okay, we'll take that off here. Well, now we know we can get an accurate measurement. So I would expect to measure nothing here because it's not working. But it's either the secondary is open or the primary is open. Either way will cause this transformer not to work, okay? So this is the secondary, we're measuring the secondary. Oops, my meter wants to get off of here. I'm measuring 6.1 ohm, okay? That means the primary is fine, okay? So now we're gonna measure, the secondary is fine. So the primary of the transformer was 120 volts, what that's hooked up to. So we'll take and measure it here. There's two wires here. Okay, this is what we call the input to the transformer. Okay, so here I'd expect to measure nothing. okay? And let's see what happened. Nothing, see, no connection. So that means the primary of this transformer is bad. So now we have double checked. See, we checked the voltage coming off of it when the power was on, and we saw nothing coming out. And so we assumed it was a transformer. Now we've done a second check with resistance from the same multimeter here. And now we figured, see, there's no resistance in this transformer. Now we know for sure that this transformer is bad, okay? So no guesswork. This is what it's all has to do with troubleshooting. Troubleshooting is not guessing, it's not assuming. It's always testing, making tests, checking things, okay? Observing things. That's how you troubleshoot, not guessing, okay? So this is how you troubleshoot and find out exactly. So we know this transformer is bad, and this looks bad here. So we could test this as well if we wanted to. We can also take this apart here. But we've seen that it's burnt already. That's a really good indication that it's no good. But we can take this apart as well. So we remove this hookup wire here, because otherwise we might get a false reading. Okay. Otherwise, this transformer on top here would. Okay, so this is not coming off. Come on, baby. Come off of there. They wrapped it around good. There we go. So now we'd assume this transformer to be bad as well. So now I'm going to take this wire here, hook it up to this white wire here, and go across, and it measures 3.7. So this is actually good, okay? So really, this is actually working, even though it's burnt. But we're still going to replace it because it's burnt, okay? So just to be sure, we're not going to have to come out and do a second call. We're going to replace this, we're going to replace that, and there's really nothing else to it other than the switch outside. Okay? I'm going to replace this now and we'll test it. So now we're looking at it. Okay, so let's look at the back of this here. Okay, right away I see a problem here. And let's see if I can bring this up a little closer, even though we are on a tripod. Let's see if you can see this here. Can you see that? Okay, there we go. If you see that lower coil, see there's burn marks on that. That's a bad sign. That means it's given out. That means the insulation has gone bad and is burnt. It's got hot and burnt. That insulation on that wire on the transformer there. Okay. Put this down again here so we can see what we're doing. Okay. So that's a bad sign right there. Okay. So here's another transformer right here. This transformer right here is part of all these old systems. This transformer is called a step-down transformer. So it has 120 volts, line voltage on one side, the house voltage, and it steps it down to about 16, 18 volts, okay? And the way it does that is that it's got more windings on the primary, which the house is hooked up to, which is 120 volts, and it's got less windings on the secondary, which is these two wires here. The other two wires are hooked up right here, these two black wires right here. And you can see they are hooked up to the house supply right here, okay? So I would expect to see 120 volts here, and I'd hope to see a voltage here of some kind, hopefully 16 volts, something like that. Okay, so I'm gonna go ahead and measure that right now, okay? So we're gonna take my meter here. This multimeter, this is a multimeter right here made by Fluke, which is my favorite meter designer. And right away when it comes up, you'll see right here, see the lines next to the V, next to the voltage. That means it's set up to measure direct current. Okay, so we don't want that. We want it to measure alternating current, AC. Okay, so now you see the little wavy things next to the volt, and now we're measuring alternating current. Okay, so now, whoops, off the ladder. So we're gonna put this right here in 1, and we're gonna check it here. See what we got. We got nothing, 0 voltage. So that means if I have 120 volts here on these 2 black wires, that means this transformer is bad, okay? So let's take these 2 off here. And I'm doing this without shutting down the circuit breaker, so watch yourself, okay? Because this is 120 volts right here. Okay, so we're gonna take this off right here, and it just comes apart. Then we're gonna take this wire off here. And again, I know what I'm doing, so but otherwise you need to watch out here. Okay, so here we have 122 volts. Okay, so now we know the line voltage is good. So now we know, since there's nothing coming out of secondary, this transformer, we know the transformer is bad. So not only is this coil bad in here, but because that went bad, this went bad as well. So it blew that transformer as well, okay, because this shorted out. Okay, so we need to replace both that and that, okay? Now I'm gonna show you another way that we can test this out as well, by using the same meter, but measuring resistance. Okay, I might as well show you that we're replacing this here. So these are the 2 terminals that the bell's hooked up to, right? So we're gonna take this off of here, this off of here. Okay. Boom. And there we go. Good, good. Okay, so now this comes off. Okay, put that right down here. So we have this wire here. We have this white wire here. These are coming from the switch. And second one here is going to here. So we have this guy here is going to the output of the transformer. So these 2 guys here are going to the output of the transformer, and the white one goes to the other side of this coil right here, okay? So we're gonna take this off right here, boom. And the screws like to fall on the ground. So we take this off right here. Boom, 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 boom. Okay, and pull these guys out. Okay, here's our unit, toast. Okay, let's put that over here. Okay, so first of all, let's get the new transformer. So here's the new transformer. Has 3 wires here. Okay, it's got the hot, the neutral, and the ground. Okay, and so the old one was only hooked up with hot and neutral. The ground wasn't hooked up. The electrician got a little lazy. So we'll hook them all 3 up this time. Okay, so black, we're gonna go black to black. And this, in this case here, this is what's called stranded wire, okay? Except the manufacturer was nice enough to solder that wire. So now it's solid, and it's much easier to work with when it's solid. And the other one here is also actually stranded wire, but it's been soldered. So now it's a solid wire, much easier to work with, especially with wire nuts. Wire nuts are not crazy about stranded wire. So the wire coming off of the 120 volts is, of course, a solid wire, okay? So I push these in, and then I shove this on here like this, and pretty much until it has pretty good resistance and it's pretty hard to turn. And you start to turn both wires. Then you know you got it pretty good. Then you can yank on it too. I'm yanking on it, I'm pulling on it, pulling on both of them, and they're not coming out. That's good. That's a good little test there. Then we're going to take another wire nut here and get these 2 together right here. Make sure they shoved in nice and deep into that wire nut. And then we're going to turn that as well. Okay. Okay. There we go. Okay. Now we're going to hook up this ground in here that is just sitting in here, was never hooked up. So now I gotta go get myself a wire nut. So okay, we're back. So we might as well hook up this ground as well. Do it properly here. So we're gonna stick this in, the first wire in here, good. And then here comes the ground. And then we'll just turn this wire on this guy too until it's hard to turn. And we'll do a little test to see if it comes out. It doesn't come out. Okay, good. So now, in this case here, this transformer is just laying inside this cavity right here, inside this double junction box right here. Okay. So now we're gonna hook up some wires to the secondary part of this transformer. And since this is AC, it doesn't matter what goes where. Okay. If it was DC with plus and minus, it would matter. But here, it doesn't matter, okay, since it's AC. So we'll take the red wire here coming from the switch at the front door. We'll take that and just put on one of these, doesn't matter which one. Okay, and we'll wrap it around here nice and tight. And wrap it one more time. Good. Now when you wrap a wire around a screw like that, it's important that you do it clockwise, okay? Because the screw is going to tighten up clockwise. And if you wrap the wire counterclockwise, when you tighten the screw, it'll tend to undo the wire from the screw. So you don't want to do that. So we're going to tighten up this screw like that. Nice and tight. There we go. Okay, so then now we have the other red wire. It doesn't matter. These wires happen to be red and white, but there could be all kinds of colors, but it's just what they used here. Okay, so we'll take the second wire, we'll wrap it around here, nice and good, nice and tight. This is easy wire. It's actually what they're, old-fashioned telephone wire. It's really thin, so we'll tighten this up as well. Okay, there we go. Boom, boom, okay. Now all we have to do, now we're gonna pop this in here just temporarily while I'm testing this out, hooking this up. So there's so now we're gonna take the brand new se vi simpelthen bare lige så skal vi have de her to skruer her på. Okay. Good. Good. Excellent. Excellent, excellent. Okay. Good. This guy likes to fall off and fall off. And this guy here falls off all the fucking time. Time to be in to him. Hop, hop, hop. Hop, hop, hop. Okay. Time to get in that pole here. Okay. Good. Okay. Then we'll take this cover, pop it on top of it. Let's see, it doesn't really matter how this goes, I guess. So we'll put that right here like this, and it's on. And now we just need to paint a little bit around it here, and it'll be fine, okay? Good. Then we'll do another little test, see what happens. I think it's working. Again, thanks for watching.